What if I told you that right now, an absolutely impenetrable fortress is being constructed right in the middle of the ocean? But, it's not a military base, it's not for soldiers. It is literally being built to capture the wind. Welcome to today's Explainer, where we're going to unpack exactly what it takes to build a megastructure in the most unforgiving water on Earth. Imagine standing out in the North Atlantic Ocean, 100 miles from the nearest shore. Out here, the water is just this churning, freezing gray. The waves hit like absolute hammers. And the wind, it never, ever stops. You don't just build a structure out there, you are basically waging a daily war against the elements just to exist. Okay, let's dive into this because the number 45 billion represents the sheer staggering stakes of this gamble. $45 billion. To put that into perspective, that's roughly the entire gross domestic product of some small nations, just being poured directly into the churning sea. This isn't just your standard construction project, right? This is a massive multi-billion-dollar bet against nature itself. Engineers are actually calling it the Ocean Fortress. And to pull this whole thing off, to keep a $45 billion investment from quite literally sinking to the bottom of the ocean floor, they've had to take the traditional engineering rulebook, rip it to shreds, and invent entirely new sciences from scratch. To really understand the mind-bending scale of these steel monsters, we need a comparison. We are talking about installing individual turbines that stand 800 feet tall. Every single one of these things is taller than the Eiffel Tower, planted right in the deep ocean. And if you were to gather up all the steel being used on the foundations for this project, you'd have enough heavy metal to build 5 complete military aircraft carriers. 5. And remember, we're out here 100 miles offshore. You can't just drive a truck to the site. The logistics of moving aircraft carrier amounts of steel on floating barges that are bobbing like corks in the ocean swells, well, it's enough to give any structural engineer severe vertigo.
Chapter 1. The Ultimate Ocean Fortress.
Chapter 2. Anchoring in Shifting Sands.
Let's see how this actually gets built, because to really understand this explainer, you have to realize that the Atlantic Ocean isn't just a location on a map. It's a hostile, chaotic antagonist. So here's the crucial point. Usually, when you build a heavy, towering structure like a skyscraper, you absolutely need solid bedrock to anchor it. But out in the deep Atlantic, there is zero bedrock at the surface. All you have is loose, constantly shifting sand. If you build heavy on wet sand, you sink. Simple as that. To stop this fortress from drowning, engineers borrowed a technique from the world's tallest buildings, using what are called suction piles. Think of them like giant, hollow steel legs. First, they drill these legs 50 meters deep into the seabed. That's deeper than a 15-story building. But here's the real genius part. To keep that wet sand from instantly collapsing back in on itself, they hold the walls back using a high-pressure slurry. Basically, they pump in this specialized, heavy mud that creates immense outward pressure, acting as a temporary liquid wall. Finally, they lower in a steel skeleton that is so incredibly dense, you could barely squeeze your arm through it. This displaces the slurry and locks the foundation into the earth. It creates this massive vacuum that literally sucks the tower down and holds it extremely tight. Chapter 3. Assembly Line for Giants. You see, fighting the ocean is only half the battle here. The other half? The clock. So how on earth do you build hundreds of these massive 800-foot structures without missing your brutal deadlines and bleeding billions of dollars in delays? Well, you completely change how you manufacture. In the past, massive turbines were built one by one. They were carefully put together, kind of like a handcrafted Swiss watch, where every single piece was slightly customized. But to hit the Ocean Fortress deadlines, they abandoned that bespoke engineering completely. Instead, they adopted the Starshield logic used by SpaceX. They took automotive production principles, think of a highly automated standardized car factory, and applying them directly to ocean megastructures. They built an entirely new factory on land, utilizing modular, perfectly uniform parts, acting as a literal assembly line for giants. And the results of this automated approach are totally staggering. Thanks to the system, a brand new, towering turbine frame rolls off the assembly line every single day. One a day. But you still have to get them 100 miles out to sea. To safely ship these massive, highly unwieldy components on specialized jack-up vessels, the colossal blades and structural wings are folded up with origami-like precision. And this isn't just about saving space on the boat. These components are actually highly delicate until they're locked into their final position. By folding them, they prevent the unpredictable ocean winds from catching them like a giant sail and capsizing the transport ships during transit. It's industrial efficiency operating on a scale that's honestly almost hard to comprehend. Chapter 4. Surviving the Atlantic Elements.
But of course, once those folded giants leave the safety of the factory and actually arrive at the site, the real battle begins. This is where the weather data becomes genuinely terrifying. It threatens not just the $45 billion structure, but the actual lives of the workers building it. Let's talk about what's in the water first. The fortress is engineered specifically to survive rogue waves. Now, rogue waves aren't just big waves. They're this crazy oceanographic phenomenon where multiple wave systems mysteriously sync up in the deep ocean to form an immense, totally unpredictable wall of water that can reach 30 meters high. They act like sudden avalanches of blunt force water that could easily swallow the lower floors of a skyscraper. So the lower decks of our ocean fortress have to be designed to take a direct, multi-ton impact from these monsters and not even flinch. They use specialized geometries that slice the wave apart rather than taking the full blunt force. And hey, if the water wasn't bad enough, consider the air. 140 kilometers per hour. Those are the kinds of brutal wind gusts hitting the workers out there. Because they're working hundreds of feet in the air, a sudden gust like that could easily throw a grown man off the structure like a piece of crumpled paper. No way you can use standard equipment out there. To survive this wind shear, engineers had to throw out normal scaffolding completely. Instead, they utilize entirely self-climbing work platforms that are fully enclosed. The workers essentially build the tower from inside a high-tech protective steel cocoon that just crawls its way up the turbine shaft. This means human beings are never directly exposed to the raw Atlantic winds. And this brilliantly illustrates the absolute zero margin for error in such a chaotic environment. Despite 140-kilometer winds and skyscrapers swallowing waves crashing right below them, the precision required is absolute. Every single tower is constantly checked by advanced laser targeting systems during installation. If an 800-foot turbine is finally bolted down to the seabed and it is even 1 single degree off from true vertical, they scrap the whole thing. Yep, you heard that right. It's perfection or nothing. Why? Well, because if an object that tall with massive blades spinning at the very top is even slightly tilted, the physics of that rotational weight will create a microscopic wobble. Over time, that wobble will literally tear the billion-dollar foundation right out of the seabed.
Now, generating the energy is one thing, but how does it actually get back to us? Through the nervous system of the fortress. They're laying thousands of kilometers of specialized 25,000-volt underwater cables. Experts compare the sheer difficulty of this to building the Channel Tunnel between England and France. Think about it. You're laying a massive, highly charged live wire in a hypercorrosive saltwater environment. Shifting sands can easily expose the cable, and powerful deep-sea currents can drag and snap it. So to lay it safely, they use specialized underwater robotic trenchers that bury the cable deep beneath the ocean floor. When you're dealing with a 25,000-volt line at the bottom of the chaotic Atlantic, one wrong move isn't just a delay, it's a permanent, catastrophic failure of the entire grid. To ensure everything is actually surviving this daily onslaught, the fortress effectively monitors itself. Each turbine is packed with over 600 embedded sensors. These sensors beam real-time health data back to mainland control rooms. Engineers watch the structural integrity, the cable tension, and the microvibrations of the fortress exactly like a doctor watches a patient's heartbeat on a monitor. And the response is completely instantaneous. If a sensor detects even a microscopic anomaly, say a bolt loosening due to a wave impact, the system can automatically shut down that specific turbine's rotation to relieve stress. It even deploys inspection drones to the site before a human engineer even finishes their morning cup of coffee.
Chapter 5: The Climax and Triumph. But look, even with the best sensors and the smartest engineers in the world, the ocean always has a surprise waiting. Because there was a terrifying moment out there where this entire $45 billion dream nearly collapsed into the sea. Deep beneath the surface, the massive drills hit a complete nightmare scenario, a zone of unpredictable fractured geology on the seabed. Instead of dense earth, the rock was brittle, just completely shattered into loose tectonic plates. No geological model, no sonar, absolutely no prediction had seen it coming. It was the exact same kind of unforeseen subsurface disaster that infamously derailed Japan's $72 billion maglev train project. Instantly, the carefully planned schedule crashed. Costs started exploding. The seabed was so fractured that the massive suction piles we talked about earlier couldn't even form a vacuum. The water just flowed through the cracks in the rock, meaning the fortress couldn't be anchored.
But the engineers absolutely refused to pack up. Instead, they executed a heroic pivot.
If the Earth was broken, well, they were going to glue it back together. They formulated a specialized, ultra-dense liquid grout that is actually heavier than seawater. Because of its sheer density, when they pumped thousands upon thousands of tons of it directly into the fractured seabed, it didn't just wash away in the ocean currents. It displaced the water, sinking deep into every single microscopic crack in the Earth. It then cured underwater, chemically bonding the loose, shattered rock into a single monolithic block. They essentially reinforced the Earth itself until the newly formed foundation was actually harder and stronger than the original, unbroken rock ever would have been. They literally turned a fatal geological flaw into their absolute greatest strength.
Chapter 6. Powering the Future Grid.
Because all of this, the 50-meter deep drilling, the SpaceX-style assembly lines, the battle against massive rogue waves and gluing together fractured Earth, it all leads to a singular world-changing payoff for you and me. When that final turbine clicks into place out there in the Atlantic, it changes our power grid forever. This single ocean fortress is capable of displacing massive amounts of fossil fuels, cleanly powering millions of homes, and it does so while operating with absolute zero emissions. It represents a fundamental, radical transformation in how we harness our planet's natural forces. But perhaps most importantly, as you pause and look at the gravity of this achievement, it proves that the impossible really can be built. People said a permanent structure couldn't survive in these waters, but human ingenuity stepped up and built it anyway. Which leaves us with this final thought to ponder today. If we can build an impossible fortress in the most unforgiving water on Earth, what other zero-emission miracles can human engineering achieve? The Ocean Fortress is just the beginning. Thank you so much for joining me for this explainer. Keep asking big questions, and I'll see you next time as we dive into the next seemingly impossible build.